Hi, now we are going to apply shift operators on negative numbers. Okay, so I'm assigning b value as -8. Okay, so on this -8 we are going to apply the shift operators. Okay, so first we have to get the binary value for -8. Okay, so as we know how to convert the number into a binary value, so we have got the binary value for 8. Okay, from this we have to get the binary value for -8. Okay, so for -8 two step we have to do. Okay, first we have to take the inverse of this numbers. Okay, so inverse means all 0 will be converted into 1 and the 1 is converted into 0. Okay, so first 3 0 we have, so I'm converting into 1. Next 0. Okay, so rest will be converted as 1. Okay, so 1 1 1. Okay, now all zeros are converted into 1 and ones are converted into 0. Okay, now we have taken the negations. Now we have to add one bit this converted value. Okay, so we are going to add +1. Okay, so 1 plus 1, that is, so we can 1 plus 1 is 0. Okay, and we have the remainder 1. So 1 plus 1, actually 1 plus 1 we will get 10, so we are placing 0 here and the remainder 1. So 1 plus 1 again 0. Okay, we have the remainder 1 again, so 1 plus 1 0. Again we get remainder 1, so 0 plus 1 1. Okay, and the rest of the value will come as it is. Okay, what we have done is we have the binary value for the number 8. We are taking the inverse of this digit. Okay, next we have to add +1. Okay, so 1 plus 1 0, the remainder is 1, so I have to add that one with this next bit. 1 plus 1 0, again 1 1 plus 1 0, again 1 1 plus 0 is 1. Okay, next the rest of the bit will come as it is. Okay, this is the binary representation of the number -8. Okay, now we have to apply the left shift. Okay, means be left shift by 2 bits. Okay, so means left shift means the left side 2 bits will get truncated, so we can copy this. So left side 2 bits got truncated and 2 zeros we will add in right side. Okay, this is the left shifted -8. Okay, so -8, 2 bits got left side shifted. Okay, now we have to convert this into a number. Okay, so if left side 1 means this represent the negative value. Okay, so we have to keep this 1 separately. Okay, so this is the negative value. We have to get the digit for this binary representation. So to convert the negative value into the decimal value, first we will take the inverse of this 0 0 0 0, means we are converting all ones into 0, zeros into ones. 1 1 1 1 1. Okay, now we got the inverted value. Again we have to add 1 with this value. can add. So 1 plus 1, 10. Okay, remainder 1. So we have to add that one with this 1. 1 plus 1, 10. So we are keeping 0 here. Okay, and the 1 plus 1, 0. Again remainder 1. 1 plus 1, 0. Remainder 1. 1 plus 1, 0. Remainder 1, and 1 will come. Okay, correct. So the rest of the zeros will come as it is. Okay, now this 1 will come like this. This is for sign bit, so we should not include for the decimal conversion. So as all we know, this is the binary representation for the number 32. So we will get 32. Here we have to check the sign. This is 1, so we have to give minus 32, right? Now we have to do the right shift operator. B right shift by 2. Okay, so we have the binary representation of minus 8. We can take that. Okay, now we have to do the right shift operator. So right shift operation means this right side 2 bit will get truncated, so we have to delete. Okay, and the left side 2 bit we have to add. Okay, so here we don't know whether we want to add 0 0 or 1 1. Okay, so how we have to add this 2 bit means we have to check the last bit. This is 1, so we have to add 1 1, not 0 0. Okay, now we got the right shifted value of minus 8. Okay, this last bit is 1, so this is the negative value, and this is the binary representation. We have to convert into the decimal value. So what we have to do is this 1 we can keep it aside. So this is the sign bit, and we have to take these bits and have to do the conversion. So first step is we have to convert the all zeros into ones and ones into zeros. 0 1. Okay, now we have taken the inverse of the bits. Okay, with this we have to add plus 1. So we can do plus 1. So 1 plus 1 0. Okay, we will get the remainder 1, and the rest of the bit will come as it is. Correct. So the conversion of this binary to decimal will give us 2. So this is the binary representation of the number 2. So here the last bit is 1. So this is the negative, this represents the negative sign, so we have to add minus 2. Okay, next we have to do a right shift with 0 fill. Okay, so B value is minus 8. We can take the binary representation of minus 8. Okay, we have to do the right shift by 2 bits. Okay, so this 2 bits will get truncated, and here what we want to do is we have to fill by 0. This is the application of this operator. Okay, so we are calling this as right shift with the 0 fill. So we don't want to check the last bit, we can directly add just 0. Okay, either that this is the right shift or left shift, but this is triple less than or greater than means that means shift with the 0 fill. Okay, so now we can check left side is the 0 value, so this is the positive number. So we don't want to do these two steps, we can directly convert this number into a decimal value. So as we have much 1, so definitely this would be a bigger number. Okay, so we can check by programming. B value is -8, we are applying the left shift means we should get -32, we are applying right shift means we should get -2, and for right shift with the 0 fill we can get the number. So here we have, so left shift by 2 is -32, right shift by 2 is -2, and right shift with the 0 fill will get this number. So here we have done the 2 bits, that means we have applied the operator only for 2 bits. If we have given 3 means the left shift or right shift will happen for 3 bits. Okay, these are the value for 3 bits shift. Yeah, thank you.